In this video, we're going to be looking at the idea of symmetry and the collection of symmetries of a geometric figure because they form an important example of groups. So to get started, I want to look at a definition. A symmetry of a geometric figure that's lying in the plane is any geometric transformation that makes the figure land on itself. Now, it's important to realize that by a geometric transformation, I mean those things that you studied in high school. The ones that you probably remember are things like translations and reflections across lines in particular, and rotations about points. Now, a translation, since it actually moves things, is going to move the whole figure, so translations are not going to be of any interest. Our symmetries are going to always be able to be understood in terms of reflections and rotations. So these are the things that are going to give rise to symmetries. To make all of this a lot more concrete, I want to look at a specific example of the symmetries of a non-square rectangle. So here's a non-square rectangle. And the first thing is I want to make it clear that if we do absolutely nothing to the rectangle, that is a geometric transformation. I call it the do-nothing transformation. Our author will call it the identity transformation. Well, if I do nothing to this particular rectangle, what happens to it, of course, is it stays the same. So if I do nothing and I kind of pull it away and sort of look at it on the before and after picture, what I see is that do nothing doesn't change the location of the vertices. Our author, as I said, calls this the identity transformation. So the do nothing takes the rectangle back to itself and leaves the labels on the vertices the same. Well, if I think about rectangles, I can do some other things with rectangles. It's also clear that if we have a non-square rectangle, that we can rotate this rectangle 180 degrees, and when we do, the rectangle lands on itself. Now, the labels of the vertices have gotten changed. That's why we're looking at double messes on my vertices. So again, what I'm going to do is I'm going to pull the image rectangle down here. And so we're taking the original rectangle into this picture. That is the 180-degree counterclockwise rotation. Now, to make the picture just a little bit easier to understand, I want to turn in these upside down labels right side up. So if I think in terms of this one, this is where A landed. And this particular thing here is where B landed. And this one here is where C landed. And this over here is where D landed. So if I do a 180 rotation of the rectangle, the original labels look like this. And the new labels look like this, but the rectangle itself hasn't been changed. Well, let's see. We can do some other symmetries on a rectangle. It is clear that if I look at the vertical line right smack down the middle of the rectangle and I flip over that line, that will be a symmetry of the non-square rectangle. So let's see what that has. So we're going to flip over that vertical line. And when we do, we notice that the vertice names have changed. We can see that more clearly if we take our image rectangle over here and note that when we do a vertical flip, we get this particular rectangle. Here again, I want to clean up the vertice names. A is actually kind of readable, but we'll clean it up anyway. B lands over here. C lands down here. And D lands over there. And so it's very clear that what goes on is these two vertices swap and these two vertices swap places when we are flipping over a vertical line. Well, a non-square rectangle has one more symmetry, and its last symmetry is flipping across its vertical line of symmetry. And so what happens when we do that? Well, let's flip this up, down. And again, you'll notice that we have weird things on the rectangle, on the labels, but the rectangle itself landed on itself. So we pull it apart and we look at what happens. So this is what happens with a horizontal flip. And if we want to actually see the picture better, we'll change these vertices to where they are right side up and left to right instead of right to left. So that's the B, and that's the C, and that's the D. And what I want to notice here is that in a horizontal flip, these two vertices swap and these two vertices swap positions, but the rectangle itself lands on itself. Well, what about other potential kinds of symmetry? If I think in terms of trying to rotate some other degree other than 180, and here I'm just going to be rotating by 90 degrees, what I want to notice is that a 90-degree rotation, the rectangle does not land on itself. So the rectangle, this is a non-square rectangle, does not land on itself after a 90-degree counterclockwise rotation. So 90 degrees counterclockwise is not a symmetry of a non-square rectangle. So before this video ends, I want to look at two other potential kinds of symmetry for a rectangle. If we have a rectangle, we might want to think in terms of reflecting the rectangle over its diagonals. And the question is whether or not that is a symmetry of the rectangle. Now, the software I'm using doesn't allow me to easily show you what happens if I try and reflect this rectangle over the line segment AC. So we'll go over into GeoGebra and see what it looks like over there. Now you'll notice that I have the same kind of a rectangle labeled in the same way along with the diagonal line AC drawn. So what I want to do is I want to select that rectangle and I want to reflect it about that line segment. And you'll notice that the rectangle does not land on itself. So the net result is that if I flip across the diagonal AC, we get this picture, and it's clear the rectangle does not land on itself. And what that means is flip across this diagonal, is not a symmetry for a non-square rectangle. As you might suspect, that if we try and flip across the other diagonal, a similar kind of thing happens. So again, let's look at what happens in GeoGebra. So here's our rectangle, and this time I've got the diagonal BD drawn, and so if I select that rectangle and I reflect it across that particular line, this is the picture that we get. So we're going to take this picture back into the notebook for our video, and there it is. And so the main thing that I want to say at this point is flipping across. BD is also not a symmetry for a non-square rectangle. And it's not a symmetry for the same way the rectangle did not land on itself.